Hey guys, hope you're having a good spring break. I don't want people to fall too far behind on the course, so I'm gonna make some videos for chapter 8. I expect today's Friday 14th, Pi Day. Guess that's a math day if you follow that stuff. Um, so I want to make some videos. By Sunday, I'll have most of them up. So please do take time to watch them. I'm thinking because the first few sections that we went over in the course were made by a different teacher, and I have no issues with them. Honestly, I think they were fair and short, but um, this stuff is way more important. So I've created all these um, I've created all these chapter 8 assignments for you guys. So I hope that the course feels a little smoother. At least that's the hope for now. And ultimately, this should feel like a little bit more familiar, right? The stuff that we did with volume, area, and all that stuff. Those are good problems, but I feel like we focused too much on them before having done some of the core materials. So like I said, I hope these videos and this chapter feels a little bit better. Let me know if you get that feeling. Let me share my screen. Okay. So honestly, guys, I could go into the book here, and it's a good book. So you guys can always do that if you go to Axis Pearson and look at the text contents. For sure that will help you. Um, but I personally am of the opinion and just gauging interactions with students that it's sometimes more helpful just to see how to do the problem. Like I know you guys have may have help down here, help me solve this for an example. And sometimes if you click this, there's videos, it's great. Um, but maybe just seeing your teacher um, do the problem is a little bit better, right? So let's just see how that goes. So I'm going to run through these somewhat quickly. Um, I don't think they're too difficult, but you're going to need to practice them, right? So just getting the answer right once is not going to help you. You're going to want to go back and do it a second time, do similar questions, and so on. So let's jump into this. So we have antiderivative uh, 21 over 7x minus 3 to the fourth dx. Um, it tells us right here to use a substitution. And we did do this in Calc 1, so it's called a U sub or U substitution. Not like a U-boat, not to be familiar with war and World War II, not like the German submarines. These are U substitutions, meaning you pick something that you want to be U, okay? I guess you can see there's a pi down here on your screen. You probably have that too if you use Windows. So it's a math day. Go. So we pick something to be U, right? What is it going to be U? Well, we have a lot of choices, and that's why it's going to be hard sometimes. The whole thing that should guide you is, so we're going to pick a U, and step 2 is really guiding us in terms of why we pick what we do, right? Whatever we don't pick to be U, it has to be related to du, right? So yeah, we have choices here, right? We don't know what's going to be right. We could let U be 21. That doesn't make sense, right? Because what's du? What's the derivative of 21? It's 0. That's not going to make sense for a substitution. You could let U be the whole thing, right? But that's not really going to make sense either, because if you took the derivative of this whole thing, you're going to get some crazy du, right? Go back to Calc 1, think about what this derivative would be, and it's not going to show up anywhere in the problem. So that's not a good choice. So the only way to get good at these is by practicing. So in this problem, and again, to me, it's going to be a little more obvious having done a bunch of these. And, um, but if you can see it, we want u to be 7x minus 3. Why? Not necessarily because that leaves us with a good du. No. We want to let u be 7x minus 3 because um, du would be 7 dx, and we kind of have that here. Okay. Now we don't have that exact thing. So let me kind of walk through that part. Notice if I pulled a 3 out, right, and I left a 7 here, then I still have the same thing, right? But notice this would be du, and this is my u. So that's the right choice. In other words, the antiderivative becomes this. I substitute du for 7 dx. And then right here, that's u to the 4th, okay? And this is a familiar integral, right? It's 3 antiderivative u to the negative 4 to the u. And when I do the power rule, I get 3u. What happens when you integrate this? You got u to the negative 3, divide by the new exponent, cancel, and you got negative u to the negative 3. Now, what that is u was 7x minus 3, so we have 7x minus 3 to the negative 3. And that is the same as 1 over 7x minus 3 cubed and plus a constant, and that's the answer. Okay. So that's question 1. Okay, good. All right, second one, sort of the same idea. Now this is basically the same problem we had before, except how we saw it before, it would have been written like this, right? The negative exponent means it's in the denominator. Ah, and so what we do is the u substitution, right? It doesn't specifically state that here, but this is a u sub. So first thing is pick a u. It should be kind of obvious here. It's most likely going to be whatever's inside the parentheses. So if we let u be 3x minus 2, then du is 3 dx. Now here's probably, in my opinion, the hardest part of math, the hardest part of Calc 2. This is stuff that gets you completely lost, so bear with me. What we're doing here is we substitute, so we substitute down here for u, right? But notice I'm not writing the other parts because this is where it gets funky. In the problem we have a 1 dx. Okay, we have a 1 dx. This 3 is a big problem. And this, like I said, it's the hardest part of Calc 2. Because we want to substitute this part out, not necessarily the 1, but the dx, we need a du there. We have to move this 3 over. Okay, so we get du over 3 is dx. Imagine a 1 right here, right? So I can substitute this for this because they're equal. So I put a du over 3, but I'll pull that 1/3 out. So it's really this, right? Then what we do is, let's write it up here, we have 1/3. Let's write 1 over u to the 9th as u to the negative 9 du. And then we use the power rule, add a 1 to that, becomes u to the negative 8 divided by negative 8, which is u to the negative 8 over negative 24. And then you plug back in for u, whatever you pick. So our u was 3x minus 2. So the answer would be 3x minus 2 to the negative 8 over negative 24, which looks terrible. but that's that. We could also write it as negative 124 times 1 over 3x minus 2 plus constant. Okay. However you want to write it. But again, you're not going to get these in one try. So, um, enter the answer and then do a similar question. Okay. So that's u sub again. Okay. So keep an eye out for what we do and what we don't. This is a great problem, but I would say this is the problem we'd actually want to see. Let's say they asked this instead, because that 18, believe it or not, is a bit of a pain. Um, so whatever. We could use some pre-calc natural log rules, but we don't need to. If we had this problem, this is really what's going to guide us here. And that's sort of the thing with Calc 2 is you're going to get problems that there's no general rule to solve them. You have to know how to do that kind of problem. So this problem is really, how do we do this one? Okay. And this one looks bad, right? We're just learning integration techniques. So far, the only tool we have is the U sub. The U sub. Okay. Now you can ask again, just like I showed you before, what do we want you to be? Do we want you to be this? These are all good ideas. Do we want it to be the whole thing? When you're doing a U sub, it's almost never picking the whole thing. So you're not going to say that's you. It's probably either this or this. Well, remember, when we pick our U, we're guided by what we want du to be. So in other words, whatever we pick u, we have to imagine taking that derivative. What would we get? So if we picked 1 over x as our u, right? What would the derivative of 1 over x be? It'd be negative 1 over x squared. We don't see that anywhere. So this is a bad choice. We don't want this to be our u. What about this? What about natural log? Well, the derivative of natural log is 1 over x. And although it's not obvious we have that, do you see how there's like sort of an invisible 1 out here over x? So we kind of have that. In other words, if this was u, then we have du already. So that's how you do these problems. It's tricky. Okay. So what we're going to do is we're going to let u be ln x, then du would be 1 over x. So that integral that I wrote before was this. Notice it's not this problem. I made a simpler problem. This would become u times du, right? Because that's what we have. So I definitely recommend looking to see that that's what we have here. In other words, we get this. And then what's the antiderivative of u to the first power? It's u squared over 2. And our u was ln of x. So it's ln x squared over 2 plus constant. Now, that will still work if that will still work if we have an 18. And I don't want to do these all, but right now I'm going to kind of get us warmed up. So we still want u to be ln 18x. It's just that our du, we're going to have some 18. So it's going to be 1 over 18x, or maybe we won't, times chain rule 18. So they cancel, we get 1 over x, that's what we have. So this actually is the same problem. So this becomes, let's write it, u times du, the antiderivative, which is going to be u squared 2. So our u is ln 18x, so it's this squared over 2, okay? And if you don't understand what I'm doing, check out the help and see if that helps too. But, I don't expect the video to make it obvious, but then again, it doesn't have to be. But we're doing u sub, and what I'm trying to convey right now is there's going to be multiple options or paths of what u could be. But you're going to kind of see by sort of trial and error, whether it's pencil math or writing it out, that one will give you the du you want and one won't. Okay. So here we go. We have two things. It should be obvious by the fourth problem. Either that's our u or that's our u. Well, usually the thing with more terms is the more likely candidate to be u, because our du should be simpler than u. Okay, so let's write that du should be simpler than u. It should have less terms. It wouldn't make sense if it had more terms. Okay. Um, so, so kind of trial and error, right? We pick u to be this because this makes sense. Now you might be like, well, what's going to happen with that 7? But watch, what's du? Derivative e to the 5x is 5 e to the 5x, right? Chain rule, 7 goes away. Now, this is what we picked to be u, so does that relate? Does this part here with the dx relate to this? Yeah, except for this 5, okay? So this is a case where, remember, this is the hardest part of Calc 2. Maybe you don't believe me, but you have to move this 5 over. And you say, this is du over 5, and that's equal to e to the 5x dx. And so what our problem is we have a u in the denominator, and we have a 1/5. So when I write du over 5, I'm imagining the du part here, and I'm imagining that over 5 out front because it's a constant. And so this is really 1/5 antiderivative du over u. And that's just natural log. So if you integrate that, what was u? U is e to the 5x plus 7. And that's the answer. Okay, plus constant. All right, so I hope this is making some sense. But remember, if you're unsure when you get the answer right, you're just like, I kind of blindly followed those steps. Try the problem again. You might have to do these 3 or 4 times, but you guys did pretty well in the first test, but I want to see some hundreds or perfect scores, so that'd be cool. Question 5. Now this is a hard problem. Okay, why? Because we have too much going on. Okay. There is a simpler version of this problem too. So if we had this, then then it's pretty obvious what u is. U is definitely going to be the thing with more terms. So u would be x squared plus 9, and our du would be 2x, which you see right here, we have that. That's great when they work out like that. What's going to happen with this one is that it won't work out like that, okay? So there's a few ways to do this problem, but this one you're going to need stuff from the textbook. So you're going to want somewhere a table of integrals. So when you're doing chapter 8, make sure you have this printed out. It's in the textbook in the appendix. Refer to that, okay? So you may or may not remember these from Calc 1. So the step I'm going to do though is you're going to be like, why'd you do that? And I'm not even sure this is how the video does it, but I'm going to assume they do. Because of what I just showed you, when we just have 2x over x squared plus 9, and we know that one works out perfectly, this plus 8 is a problem. So what we want to do is write this as two integrals, okay? Like that. And this one is basically this substitution that I did. So you'd let u be this, and this is going to be your du, except you're going to have a half out front, and you integrate it, and you get natural log. Let's talk about this one. So the first, you should be able to do this one by now. This one you're going to be stuck on. So let's talk about that. So can you think of how we would want to do this, right? Well, again, you're only going to know it if you have a clear idea of tables. So that's from the back of the book. So make sure you refer to that. We could say that this is equal to 8, pull the 8 out, times spread dx up here. And this is actually a known formula, right? So I'm not doing any magic. There's no u sub for this. It's just a known integral, meaning I have to recognize that it has a certain form. And what that form is it's 8 times the antiderivative of x squared plus, I could write 9 as 3 squared because it's a perfect square. And this is a known formula when you have x squared plus a number squared, that it's known to be arctan. Okay, so this is 8 arctan of 3x. Okay, again, that's just the formula. Okay, so make sure you have that. Just Google table of integrals and refer to it for this chapter. Okay, but this is a really, really important chapter, so let's make sure we treat it that way. Okay. Completing the square. So this one's not too bad, although I'll tell you something about completing the square. I tutored probably starting when I was late 20s, so right when I was getting into teaching in grad school. Um, and completing the square is probably, and I don't say this lightly, it's probably the hardest thing I've ever tutored in math. Tutored, not as a student, but as a tutor. Okay, it's just not something that we are familiar with. So what they're asking us to do, and again, if you don't know completing the square, look it up, practice that. When you complete the square, as long as the number in front of x squared is 1, we're good, sort of. What we do is we focus in on this, the first two terms, the x squared part and the x part. And we divide that number in front of x by 2. So if you divide -2 by 2, you get -1. And then we square that. And then we see what we created, okay? So what would we have created if we squared this out? We'd have x squared minus 2x plus 1. But since we have a plus 101, this wouldn't make sense, right? Because this plus 1 and this would make 102. We don't have that. So to account for that, we'd have to subtract that extra 1, and that will balance it out. But since this is equal to this squared, we can simplify this part to become 100, and you see, voila, that's magic, right? So what we have is 1 over x minus 1 squared plus 100, but again, we have a perfect square. So we have 1 over x minus 1 squared plus 10 squared. Oh, what do we want to do? Well, let me rewrite this. So we have this. We're going to say this is 10 squared. And then this becomes a u sub, where u is x minus 1, and du is 1 dx. And watch what happens. We have this du over u squared plus 10 squared. And we just saw that's going to be arctan of 10u, but what was u? U was x minus 1, so this becomes arctan 10 times x minus 1. That's the answer, okay? So that one's tricky, but the whole point of this chapter and how I pick these problems is for you to just be able to drill through these. So make sure you're not just going through the problem hardly knowing what you did. That's the worst way, and that's the worst feeling in math when you're like, oh, I remember question 2. I got it right, but I have no idea what I did. That's not good. Because then, then you're just going to be like, come test time, you're like, what do I do? How do I do this? Now, I did look, and I've handpicked all these problems, guys. So if you hate them, that's on me. I apologize, but I think you'll like this chapter a lot more than what we did. And you can already get a feel based on 8.1 what the test 2 is going to look like. And I'll say more about that in the next week when our test is. But it's probably early first week of April, we'll have our second test. So you don't want to fall behind on this stuff. And we're probably going to have 2 chapters on there, but most of it's going to be chapter 8 because it's a major chapter. So this problem, I honestly sat and stared at, and I was like, why did I pick this one? Notice there's no real help, right? There's no help down here. So this is one of the reasons to watch the videos. The way I did it, and it seemed to work, is, and you guys can think, if you want to think for yourself and don't want to hear the answer, then pause the video. But I sat and stared at it, and I was like, okay, this isn't u sub, right? It doesn't work. So you could try to u sub, you could try to factor. Neither of these factor well, though. You can't really factor and cancel stuff. You can't do a u sub. You can't do partial fractions, which is something we haven't gone over yet. We'll be going over that soon, like 8.3 or 8.4. This is, after staring at it for a while, a problem way back from pre-calc, and it's called polynomial long division. No, I don't think you can do synthetic division, so this is just polynomial division. And so what we're going to do is we're going to actually, this says to divide, so minus the integral sign says divide. So that's what we're going to do. We're going to divide. X squared times what gives you x cubed x, and then we multiply back through each term. Plus x squared plus 2x, and then we subtract, and then we got 2x squared plus 4x, bring down that 5, right? Then I say, how many times is x squared? So it's only the leading term into the leading term. I don't care about these two or these. I just say, how many times is x squared going to 2x squared? That's 2 times plus 2. Multiply it back through. And then you get 2x plus 1. And so what this means is when we do division, we can say that this whole thing is the same as x plus 2 plus the remainder over the divisor. So x squared plus x plus 2. And so I can say I'm integrating this and I'm integrating this. This one's a really easy one. And this one I'll let you try, but that's a u sub. So my u would be this, and I perfectly get du. Okay, so hopefully that helps you guys. If you need more help, let me know. Last one is funky, and I also stared at this for a sec. I had to kind of cheat and look at the help. It's not that I couldn't do it, it's just this is a weird one that I'm not used to, and I thought the way this is given to us, I thought it was some kind of weird trig identity when it's not. So if you're thinking about how to do this, I'll give you, if you want to pause, think about it. But you multiply top and bottom by sort of the conjugate. So you multiply, and you do have to know some trig here. I'm not going to go crazy with trig in the course, but you do need to know it for this problem at least. And then, so what's going to happen is we got 15 plus 15 cos 5x, and we're hoping to be able to do some kind of u sub. And we got 1 minus sine squared, oh, sorry, cosine squared 5x. And we can use a trig identity that this is 15. The 15 is annoying, right? But 15 cos 5 over sine squared 5x. And then this could be u, and this could be du. At least for this part, guys, you might have to split this into two integrals. And if, I'm not going super in depth in this because I don't want to do all the problems, but it's probably this plus this. So I split it into two fractions. This one's a u sub. And then this one can be written as antiderivative 15 of what happens if I bring sine up? It would be cosecant. And there's probably an identity in the back of the book in the table of integrals for that one. All right, so that's it for 8.1. I still have a bunch of videos to make, but I didn't want to leave you guys hanging. So please watch the video and let me know if it helps at all. I hope you guys really enjoy this chapter. It is gonna be challenging, okay, but you'll learn a lot. So, all right, that's it.